Hello. The video you are watching is about the numbering systems. Actually, we are going to see the decimal, the binary, the octal, the hexadecimal, and the BCD numbering systems. Let's get started with the numbering system that is called decimal. The decimal number system has to do with numbers that can be written as multiplication between a number and a number and a power of 10. As you can see here, for example, we have 472 to express it in a sum of multiplications with the power of 10. 400, this is expressed as 4 times 10 to the power of 2. 70 means 7 times 10 to the power of 1. 2 means 2 times 1, which means 10 to the power of 0. And this is how we express the decimal numbers. The binary numbering system now is a numeral system with base 2. It uses only these two digits, the 0 and 1, and each position in a binary number represents a power of 2. We are going to see an example right away. Convert the binary number 1011. This means that it is a base of 2. Okay, it is a binary system, this number 2, to decimal. We have this number, we write it here in a way of table to make the explanation more clear. We have 1011. Now we are going to express everything with multiplication between the number that we have in the first row with the power of 2. So 1 times 2 to the power of 0. 1 times 2 to the power of 1. 0 times 2 squared, and 1 times 2 to the power of 3. You can see that everything is expressed with a power of 2. So after this multiplication, we get 1 in the first column, 2 to the second, 1 times 2 makes 2, 0 to the third, and finally 8. So, as a result, we have the sum of these four numbers, 8 plus 0 plus 2 plus 1, and we get 11. This is a binary to decimal conversion. You can see again the video in order to have better performance when you try to make these conversions. We continue now with a conversion from decimal to binary. So we have an example here. We have to convert 13 with a base of 10, a decimal number, to binary. What we do every time we listen about a conversion from decimal to something else, this means that this decimal number will be divided by will be divided first of all by 2. Okay, because this is the binary conversion. If it was to octal system, would be divided by 8. If it was hexadecimal to hexadecimal system, from decimal would be divided by 16. Okay, so now we have the decimal to binary. We start from 13, we divide by 2, and as we can realize, we have a remainder to be 1, because 2 times 6 gives me 12, so until 13 we have a remainder to be 1. We continue, we get this 6 and we divide again by 2. Always we divide by 2, you can see, and we get 3, so the remainder is 0. Now we get 3 and we divide by 2. This means that we have a remainder 1 because 2 times 1 makes 2. So until we reach 3, we need one more. Uh, one more. After we get this one, and we arrive to 1 divided by 2. 1 divided by 2 cannot give us anything. Okay, so we have 1 to be the remainder. We do not have a whole. That is a whole number here. That's what I mean. We get a 0, so we have the remainder to be 1. Okay, so our number is 1101. The number 13, which was decimal, has been converted to a binary number 1101. We continue now with the hexadecimal numbering system. And actually we are going to see also the conversion between from hexadecimal to decimal and vice versa. The hexadecimal numbering system has to do with numbers that have base the number 16. Number 16 is the base of these numbers. So we have 16 symbols, we have 16 figures, we have 0, 1, 2, 3, 4, 5 until 9. And after, because we do not have more digits to express the rest of the numbers, we use the letters A, that means to be number 10, B, that means to be 11, and so on until F, which means to be number 15. So we have 16 symbols. Okay, let's convert now the hexadecimal number 2F with the base 16, as you can see here, to decimal. What we do? The same thing that we have done the other times with the other numeric systems. We write in the first row of the table 2 and F, because these are the two digits, 2 and F. Now, the F now is meant to be 15. Okay, so we write 15 times 16 to the power of 0. And here is 16 to the power of 1 multiplied by 2. Okay, as we used to make, as we used to do. So we get 15 from here and 32. Finally, we add these two and we get 47. 47 is our decimal number. So we repeat the same procedure. We write in the first row the number that they have given us, and we make the multiplications with the powers of 16. We continue now with the opposite direction, decimal to hexadecimal. Remember what we have said, when we go from decimal to something else, we make division. So the same thing we are going to do now here. We have 156 to be the decimal number. We divide by 16, we get 9. And the remainder to be 12. Yes, but 12 means C, according to our rules that we have seen before. After we get 9, 9 divided by 16, we get 0 as a quotient and 9 as a remainder. Okay, so our number is 9C in the hexadecimal system. And this is the conversion from the decimal to hexadecimal. In order to make this conversion, we are going to use this table that will help us. Each binary group of 3 digits will be represented by the octal in a way that we are going to refer now. So we have the binary number 110101 and 1. How we are going to work? We are going to group in 3 digits, these three together, but we have here only 1. So, in the empty spaces of the 2 places that are missing, we are going to use 0, 0. So, the first group of numbers will be 0, 0, 1. The second one will be 1, 0, 1. And the third one will be 0, 1, 1 here. Now, we are going to use this table, and we can make it very fast, because when you see 0, 0, 1, you are going to use the binary way. The 0, 0, 1 means 2 to the power of 0. Here is 0 times 2 to the power 1, and here is the 0 times 2 to the power of 2. So 2 to the power of 0 gives me 1, and I get 1. Okay? So if I have the 101, what does this mean? 101 is here. The 101, we have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. I multiply by 1 everything, 0 here and 1 here. So what we get from here, we get 1. This is cancelled, and here we have 4. So 4 plus 1 makes me 5, and I get 101 to be 5. Now after, in the end, the 011, what will be the 011? The 011, the last group, I will use again the 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. I multiply with the first row, 1 times 2, 1 times 2 to the power of... Okay, so what do I get? 3. Because this one is 1, and this one gives me 2. 2 plus 1, 2 plus 1 from these two gives me 3. Okay, so this is the conversion from binary to octal. The same thing happens when I have an octal number to convert it to binary. I'm going to use again this table. So if I have 1, 5, 3, very easily, I see here 1, that is meant to be 0, 0, 1. I have 5, which is this, and this is meant to be 1, 0, 1, and I have also 3. Where is 3? Here. 1, 0, 0, 1, 1. So this is my 3 bits groups, and I write full all my binary number. Okay, the only thing here is to be able to convert in group of 3 digits the numbers. Number 1, how can I write it in 3 digits with 0 and 1 combination? How can I write number 5 in 3 digits in 0 and 1 in a binary way, with 3 digits? Okay, so the binary and octal have relation, because the 8 can be written in 2 to the power of 3. So you can see they have a straight relation. That is why we can have it in a table like you see in this presentation. Now let's talk about the BCD, the binary coded decimal. What do we have here? Here, every digit, we have the group of 4 digits now. The binary coded decimal is converted for the decimal number. Is a special purpose numeric coding scheme. Okay, it's not a positional number system like the binary octal and so on. And you see, the decimal digit 0 is written in 4 bits, 0000. Number 1 is written again in 4 bits in a binary way, okay? You can realize here that we have the binary way that is expressed 0 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. So this is the 001 expression, and so on. So let's see a few examples of conversions from decimal, the decimal 259, 259 to BCD. We have every digit 259. We are going every digit to convert it to a binary number of 4 bits. Okay, number two is 0010, as we can see here. Number 5, number 5 0101, we put it here. And number 9 is over here 1009, and we apply it in this cell. So our BCD is this number. Please be careful here. If we convert this binary number, don't see that as one, it is in groups, in 3 groups of 4 bits. If we convert this to a decimal number, it will not, are not going to get 259. Okay, be careful. The BCD, it is not the conversion from decimal digit, from decimal numbers to binary. Okay, the BCD means that I convert every digit in binary. Okay, we are going to make the opposite now procedure. The BCD is 0100, 011 to decimal. We are going to use this table. The BCD group, we have 0100, 0111. So we get the decimal digit will be the first one, 0100, which is here. You can see 4. And this is why we need to be able, in a fast and easy way, to convert from digital to binary. This must be like we get the spoon to eat. And 0111, it is number 7. Finally, we have 47. Okay. This was our presentation for the numbering systems. Study well, see again the video, and if you have any questions, we are going to discuss it.